Hi, and welcome to another episode of Days from the GIS. This is your host, Eduard Roccatello, and today we will talk about LiDAR processing in QGIS 3.32. And the first thing to do is to have a nice LiDAR. Let me show you something before. This is the cloud we're going to work on using QGIS. This is open in Cloud Compare. Actually, this is a clip from a larger file, but it's quite dense. And at this moment, QGIS has a few issues to index big clouds, in my opinion. So to take a look to very big files, Cloud Compare is still better. It actually works in 3D. But let's move on QGIS, and let's take a file. That file. It will drag in a file, a LiDAR file in QGIS. Will bring a red dashed square, and QGIS will start indexing that file. Actually, it does another thing. It creates a companion file in the cloud-oriented point cloud format, and it is also compressed. And this allows QGIS to do this very fast rendering, but it takes a while, like I said before, to create this kind of rendering. So if you drop a really large file, you will have to wait a bit. So the news in this version is found in the processing toolbox. So if you don't have a processing toolbox, open it with the toolbox button here on the top, the center of the toolbar, and you will find 3 sections: point cloud conversion, point cloud data management, and point cloud extraction. The first thing is to gain information about the cloud. If we double click information under data management in the processing toolbox, dialog will pop up, and we will choose the input layer QGIS tutorial, and we will click run. And clicking run, you will get some information. It's a last 1.1.2 with a point format 3, and it has about 1.5 million points. You can see the offset, the extent, and an interesting information is that we don't have a CRS set, and we have a lot of attributes. So we may go on with the assign projection data management, and if you pay attention here, you will see QGIS blaming that the CRS was undefined, so we need to fix that. As the first thing, click assign projection in the point cloud data management here in the processing toolbox, and then select the input layer QGIS tutorial, and the desired CRS in this case will be the RNDT RDN 2008. It's actually RNDT in Italy, and the output layer will be a temporary one, but okay, let's persist it after. Okay, it will use Peter Wrench. As you can see here, it calls Peter Wrench with the translate, assign the CRS ESPG 6708 with using 12 threads. Okay, so now we have here the output layer. We may serialize this. Say, oh, sorry. Oh, save as, and last point cloud. Let's save it in the usual folder, the LiDAR, and we may call it QGIS tutorial reference. Okay, perfect. Okay, let's wait a bit. It takes a few seconds for about 2 million points. It depends on your computer performance. And you will get it indexed as well, as you can see here. This is referenced, and we have a copy in the COBC format. Okay, let's take this out. Let's set the ESPG to the right one. Okay, let's import again the file. As you can see now, QGIS will not blame anymore. And we may want, for instance, to reproject this. It's quite easy. So you have to select your target CRS. Maybe we want to move it into the another zone. WGS 84 zone 32 north. And we may click run. And after a while, you will find a new file, which is reprojected. Actually overlaying the old one, but it is in another projection. Also, we can I can take this out. So okay, QGIS tutorial reference is our file, and we may want to do a tiling. If you think to a 50 million points cloud, you want to split it. So you may want to select your input layer. You may have more than one, and you create a regular grid for this. You can assign a CRS. We can keep the right one, and we may want to change the tile length to 100 meter. And let's save to a directory. So let's create a new one called tiling. And let's save it in here. Let's click run. Oh, that's not good. Okay, let me restart QGIS. With this occasion, I should tell you that when you use a new software, you may find some bugs, and it should be okay now. Okay, let me try this. It's a new software, so okay, now it's working. Restarting QGIS always work. Okay, now if you take a look, I do a little error. Okay, let me put 50 meters. The input layers, it's always the same. Okay, let's assign a CRS, always the same directory. Let's click run. Okay, perfect. Now we have a few files more. Let me take Let me take this out and import that in QGIS. So as you can see now, we have a tiling of the zone, and we have a few files being created from QGIS, actually from LiDAR range. This is a nice front end. Okay, now we can, for instance, change something. Okay, this two, we want to merge that. And we may want to merge 2 and 1 dash 0. Okay, let me click OK. We may want to filter an expression if you want to filter something about the classification, for instance, or the intensity or the color. And we can also set the cropping extent, but we don't care actually right now. So let's click run. It will call Peter range, and it will fail. So why the heck is failing? Cropping extent is from layout map. No. Okay, let's put a cropping extent. No, it crashed. Take out. Save to a file. I call it mergo. Run. Okay, not using a temporary file works. And we have the file merged here. So we have merged 2 tiles in one. And this is great because you can extract portions of files. Also, let's move to the, let me remove that, all of that, and let's enable the first one. We can also clip a LiDAR file, but to do that, we need to have a clipping polygon. So let's create a new vector temporary layer. So layer, create layer, temporary scratch, polygon here, cutting. Okay, no other things. Perfect. Let's add a nice feature, a squared one. We may want it here. Okay, we may want to save it. It blames it cannot open the file. So let's save and try it again. Oh no, still nothing. This is the okay, ship file is okay. Let's put it in the same directory here. Okay, cut. Okay, let me edit again for safety reasons. Okay, let's input layer, cut. Okay, let's run again. It won't work. So maybe we want to switch to a file, cut, run. Okay, it's working. As you can see here, we have the cut which has been which we wanted, and it actually works. So let's move on again with another possible feature here. You may want to okay, let me enable this again. You may want to filter something. You may want to filter by intensity, where we want only intensity which is above 100. And let's click run. Oh no. So this version needs to have files saved. So let's save the file in the file, and it will works. They will probably fix this. If you want to investigate a bit, take a look to the source of QGIS and fix it. So this is nice because it's open source. Okay, now it's filtered. As you can see, we have only the intensity above 100. And we may also have the density. And density is a nice way to create a raster where each cells contain the numbers of points. And let's save it to a file because we don't want surprises anymore. Let's click run with the, as you can see, you can see where points are more dense than the other parts. So where it's black, there's only a few points, whereas white, there is about 2,000 points. This is good to have a few metrics in an easy way. So for quality checking. Boundary. Also, it computes the boundary of the LiDAR. So let's save to a file to see. Let's count bounds. And wait a bit. Okay. And it's wrong. So it is the boundary, should be the nervous shape of the points. Maybe we have some sort of scattering, but it should not be. I will investigate further about this. This is interesting. It may be a bug of BDAR. So, okay. Okay, let's move on. You may also want to export as a raster, and you may use a few attributes to do that. The X, the Y, the Z, the intensity. Usually we like intensity. And the density of the raster is 1 pixel per meter. The tile size is intended to be the size of the tile that is per thread. And advanced parameters, we don't care about that. Okay, let's use a raster here. Let's input raster here. Click run. And okay, this is a representation of the LiDAR in a file. So it's quite nice to have to create an image using the LiDAR itself. So we can convert format. And you can change the format you want. So save it to a file. You may start with the last file, which is uncompressed, to create the one which is compressed, or it is another format, which is a cloud-oriented point cloud, which is actually an octree with made by small LAS files, and we may want to create that. The other one is a virtual point cloud, so it's a cloud is a wrapper for many files. So you open one and you have a proxy for other files. It's in automatically. Okay, no. If you want to do that, it's wrong. Okay, run. Okay, okay, something wrong happened here. So let's try with the LED file alone. LED file is working. Well, if you want a COPC, we may want to use the create COPC, and may want to input layer here. Okay, let's run. Okay, it's already created, so there is no problem. This command is quite useful if you don't have a COPC, because if we take out the COPC here and we want to create it, you may want to select the QGIS tutorial reference LAS as a file, which is not actually loaded in QGIS. I've deleted the index. Let's click OK, and let's click run. It will take a while to do that. And after this process, you may want to import the file in QGIS, and we'll open it up in a second. So you prepare the file here, which is really nice. The last thing I want to talk about is the thin operator. We can work by sampling radius or by skipping points. Let's take a look. You may want to set the number of points to skip, maybe 4. And let's look in one. Okay, no, I want a less file. So let's edit this. Let's click run. Okay. As you can see, we have less density because we are skipping 4 points. So skip a point, and add a point, skip 4, and so on. The other thing we can do, I'll keep thing 1, is working by sampling radius. Maybe we want a point every sampling radius, so 2.5. So it's sampling radius is 2.5 meters. Let's save it to a file. Let's call it thing2. Thing2. This time I'll read it as satellites here. Run. Okay. As you can see, it's very coarse. You can change it, obviously. Let's do it again using this one. 1 meter is okay. Now let's thing2. Okay, run. Okay, it is a bit denser. You can choose your operators to obtain whatever you want. So, okay, this is a nice overview of the tools in QGIS. Actually, QGIS in this phase is a wrapper of the all PDAL stuff. So it is nice to have, but not fundamental, in my opinion. The really nice thing is to have all the instruments and tools in one place. So with time, we will see more and more feature about cloud point clouds in QGIS. This is really good and nice to have. So I hope this short tutorial will satisfy you, and thank you for listening. Add a comment if you like. Remember to click the like button and to subscribe to the channel. Thank you for listening.